factor each completely. Okay, so if you see a quadratic trinomial like this with a leading coefficient of 1, how do you factor it? It is factorable. So C is out. Right, we're looking for two numbers. Those two numbers need to add up to equal negative 12, and you need to be able to multiply them and get a 35. Well, what are some numbers that multiply to get 35? Okay, shh, calm down, calm down.
It's the
But then we run into a problem because if you do 7 plus 5, that does not equal negative 12.
it's A.
They both have to be negative because even though you make both of them negative, they'll still multiply to a positive, but then they'll add up to negative 12, so it is A. Okay, B was obviously wrong because, yeah, that'll multiply to 35, but no way that it'll add up to 12 or negative 12. Okay, number 2. Shh. A. A is the answer. Number 2. 3p squared minus 15p minus 42. What's different about this one compared to number 1? Right, we have a leading coefficient of 3. So you can't just go straight to adding to get this, multiplying to get this, because you would just be ignoring the 3, and you can't do that. What do you have to do with it? What's it called? GCF, greatest common factor. So we factor it out, and when you're factoring it out, what operation are you actually doing? Division, very good. What's 3p squared divided by 3? 1p squared. What's negative 15p divided by 3? And then what's negative 42 divided by 3? Negative 14. Now what we have remaining, we can just do the bubble method like we did for number 1. But you do have to remember to continue bringing down the 3 so it's not B, correct? All right, now, it's obvious that you have to have a P in each one, and you have to have a 2 and a 7, because look at all your answers. They're all 2s and 7s. But to get to the multiply to a negative 14, what kind of signs do you have to have? One positive, one negative. So does it need to be positive 2 minus 7 to get a negative 5, or negative 2 plus 7?
I mean, you already know it's D because if you remove the D and it makes D, it's obviously that, and just a P.
Right. And I knew that A was out because you can't have the same sign. They have to be opposite to multiply to a negative number. Shh, guys, you're talking way too much. Number 3. Solve each equation with the quadratic formula. Okay, well, to be able to do the quadratic formula, you kind of have to know it. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. To be able to use that formula, you first have to do what? Figure out what a, b, and c are so that you can fill it in. Okay, for this particular problem, what's A equal? B and C. Okay, so now let's fill it in. You tell me what to write. Which is 5 squared minus
2
times 2 times 4 all over
5
times 2, which is 4, correct. Okay, now, a lot of times the mistake I see is kids forget to put parentheses around this number, which in this particular problem would be okay because it's positive. But if that number is ever negative and you don't put parentheses around it, it's going to mess up your discriminant. So, positive or negative, I would just stay in the habit of putting parentheses, okay? Now we need to reduce the discriminant. What does the discriminant become? Negative 7, okay. So let's look and let's cancel out some things that definitely could not work. Okay, well look over here. We know it has to start with negative 5, so that removes C. We now know that since it's the square root of a negative number, we're going to have what in the answer? An I. So that gets rid of A and B, so it has to be D.
Yes, that's B.
Think about it. At this point, you would just Leave the square root of 7 as it is, but the negative you would write an I and then over 4. Now, we always write the answer like this, just one time with the plus and the minus. On the answers, they split it up, but that makes sense to y'all, right? How they just split it? It's the exact same thing. They just split it and put the plus on this one and the minus on this one. It's easier just to write it once and put that sign on both. Okay? All right, now let's do number 4. Okay, number 4 is the same type of problem. It tells you to use the quadratic formula. But to do that, we first have to identify the A, B, and C. What's A? 8. What's B? And C? Okay, now you tell me what it'll look like when plugged in. Which is, okay, why, if the formula is negative b, where's the negative? It was already negative. So a negative 6 became a positive 6. Now we can simplify the discriminant, so type in the discriminant. Don't forget the parentheses. Thank you, Jacob. And that's correct, negative 252. Okay, so tell me something you know. It's going to have an I because you're square rooting a negative number. So that rules out C and D. Okay, now you really don't have to worry about factor treeing 252. Does anybody know why? No. Type in square root of 252. It's not a perfect square. So, yes, we would need to factor tree it, but there's a way I can know without even worrying about the factor tree. Well, look at our answers. Look, we have a 3 and a negative 3. If you're doing 6 over 16, is that going to reduce to positive 3 over 8 or negative 3 over 8? Positive. There's no negative on either one of those. So it's going to reduce to positive 3 over 8. Okay? Now let me give you one other hint real quick. This is the last thing. Say that you're trying to factor tree 252. And that's, kind of bigger. So you're probably going to think, okay, what times what? Well, look, we have 7s in all of these radicals. So maybe you should think 7 times what is 252? Use your calculator. Use your calculator. What's 252 divided by 7? Okay, so then you'd have your first two factors and you'd go from there. So if you're having trouble thinking of the first two numbers, use your answers to help you get started. Okay, listen. 10 square tomorrow over pages 13 through 25. You need to finish the test review tonight. We will go over it tomorrow after the 10 square. When is the test?
Friday.